for, and RPM etc. generally is given, and all those things, that means like leaves etc. So whatever data it is given, for initially your first task will be to find out all those data, note those down properly, and look for what kind of follower we are talking about. Okay, whether it's a roller follower like mushroom or flat flash follower or knife edge type of follower. Based on that, your designing of cam profile will be somewhat different. Okay, those things in the last club problem we have. Similarly, yes, you have to see whether it is inline type of cam and follower arrangement or it's a offset type. Okay, so generally if nothing is being specified, then you consider it as inline type, then your task becomes easy. Okay, so or otherwise if sometimes offset distance is given or directly it is said that it is offset, then you must definitely have to go for that offset type of arrangement only. So there is no way out. But if nothing is being specified, you go for inline arrangement. Just note, write it down. That means we are just specify it in the while solving the question. Okay, that we have considered inline type of cam and follower arrangement. Okay, so next thing will be basically after that, after noting all those things, so the two main steps which are there in case of cam profile construction is, first is you have to draw the displacement diagram properly, considering the proper scale and all. Okay, and next with respect to the displacement diagram, okay, we have to draw the cam profile. So while drawing the cam profile, you have to see what's kind of, whether it is roller follower, knife edge follower, etc. And based on that, the smaller circle you have to draw. And there are all those, once again, the divisions etc. has to be done, all those SN angle, DSN angle etc. And they has to be divided with the same equal space division, same number of equal space division that you have considered for dividing the SN stroke as well as DSN stroke in case of the your displacement diagram. Okay, so all those points etc. will correspond to all those nomenclature that you have used in the displacement diagram, same nomenclature to designate the similar points in the cam profile. Okay, or design in the next step of the drawing of cam profile. So the names, the nomenclature that you will be using should correspond to the, or so should correlate to the displacement diagram. That's why it is very important, the first step, which is the drawing of the displacement diagram. So it is very important to draw the displacement diagram very properly. Okay, so all of you should be able to draw the displacement diagram properly. And yes, once again, it is, the scale is very important, as we have already discussed. So considering proper scale is very important. Okay, because everything, the whole the construction of cam profile, in that construction of cam profile, if you can recall from the last problem, so basically the distances, the extension distances we consider from the displacement diagram only. Okay, so those are the main steps involved. And if, as we are saying about scale, so if we are talking about displacement diagram, then that along x-axis we consider the cam rotation angle theta. That means suppose 20 degree equal 1 centimeter or so, whatever scale you consider, you have to note it down. Similarly, along y-axis it is displacement of the follower only, that is length only. Okay, so in that particular case, suppose 1:1, that is suppose 1 millimeter itself designates 1 millimeter or so on, whatever is your depending on what is the value given and what is your page structure, that is the size of the page etc. Depending on that, you will be considering the proper scale. Okay, and in the second step, that is the designing of cam profile, prior to the second step, you have to just write down the assumptions, because what we do is we design the cam profile based on the kinematic inversion principle, where we consider the follower is rotating around the cam, which is actually not the case. Okay, actually cam is rotating member and follower is, suppose if it is said that is reciprocating follower, then it's on the same, it will not change the axis of movement. Okay, but right now while designing for purpose, okay, what we'll consider the kinematic inversion principle, which means that we'll consider the follower is rotating around the cam in the opposite direction of movement of the cam. That means if you consider cam is rotating in the clockwise direction, we have to write down the assumption like this. Okay, cam is rotating in the clockwise direction, so we'll consider your follower is rotating around the cam in the anti-clockwise direction. Similarly, suppose whatever is the minimum radius, so depending on whether it is knife edge follower, if it is knife edge follower, the circle that you have to draw will be directly equal to the minimum radius that is given. Okay, RC. If it is roller follower, that circle that you have to consider is up to the trace point, it is nothing but the your this one, what to say, RC plus RR. Okay, so that is the roller radius. So like this. So I hope those who have also missed the class or like this, okay, at least the scheme how to do that, it's what are the steps, that is you have understood, right? Just let me know. Someone can unmute and let me know.
Understood, sir.
Okay, thank you. So now today will be, I hope most of you have already joined. So today we'll be going for the next, we'll see the next one. Okay, next problem. So you can take out the PPT or that note that is there, or I have already shared. I think it's already visible. So now first step will be like you definitely have to go through whatever is the question is given, and from there you find out all the whatever given data it is there. Okay, so in this particular problem, all those given data it is directly like this only as a short ways only it is directly given. So we'll just go through it. Okay, so what does it state? The following data relate to a cam profile in which the follower moves with uniform acceleration and deceleration during both ascent as well as descent stroke. So now from here what we have understood, definitely it's a cam profile construction problem only. And what is the scheme of movement in both ascent as well as in descent? It is uniform acceleration and deceleration. So that means while drawing the displacement diagram, we have to draw in the way, or we have to construct in a way in which we have to construct displacement diagram for uniform acceleration and retardation scheme. Okay, next what is given? So minimum radius of the cam is given. Okay, so all those things you just have to note down. Minimum radius, R, we denote it with R suffix C, it is 25 mm. It is roller radius, okay, not diameter. Diameter is actually 15 mm, so it is wrongly given in the question in the book. So it is roller radius is 7.5 meters. So roller radius R suffix R. Lift is given as 28 mm. So with H or X, whatever you consider, okay, H or X, it is 28 mm. Next, it is given that offset of follower axis. Okay, so from here, automatically we will understand if offset of follower axis is given. So it's a inline arrangement of cam and follower or offset type of cam and follower arrangement.
Offset, sir.
Definitely, it's a offset type. Okay, that's why only offset value is given. So you can write down. You have to denote offset. Here they are denoting with X, so don't use X. Okay, so whatever nomenclature that you use, you just mention it. Okay, it is up to you. Offset 12 mm, so mention it is towards right side. Okay, so it may be offset in the left or whatever. Okay, but right now offset is towards right. Okay, that means offset is towards right means, so from the, if it is suppose if it is the cam, okay, so if it is the axis of rotation of the, if it is passing through this, okay, it is going like this, then so it is roller, it is okay, so as yes, roller radius is given, so from here what we understand, it's a roller follower. Yes, if roller radius is given, so it's a roller follower, it's not a knife edge or something like this, so we can very easily understand this thing. Okay, so now in that particular case, if it's offset of follower is given, that means if this is the about this axis, if the cam is rotating, then somewhere, suppose somewhere here towards the right, that is okay, making 12 mm. So somewhere here your this roller is here, roller follower is somewhere here. Okay, this is the offset arrangement. Okay, so basically the situation is something like this. Next, so we have denoted it. Next, what is given? Angle of ascent 60 degree, angle of descent 90 degree. Okay, you can use phi ascent for A, okay, or right stroke, psi suffix A or like that, or theta also you can use, that is up to you. Just denote it properly. Write it down, suppose angle of ascent, and after that phi or theta, whatever you use, suffix A for ascent. Next, what you will do for your proper so that you don't later on make mistake. So for that case, once when you write about angle of ascent or angle of descent, in bracket you mention about what was the scheme of movement. Sometimes what may happen in both the angle of in ascent and descent stroke, the scheme of movement might be different, just like in the previous solve example. Okay, so here uniform acceleration and retardation, uniform acceleration and retardation. So I am just write U, A, and R, but you should not write like this. Okay, so it is just only for like your understanding purpose for right now. Okay. Similarly, angle of duel between ascent and descent. That means we must understand that it is starting from the ascent, then we have a duel, then we have the descent. So duel with del we denote. Okay. So first duel. So del suffix a. Okay. 45 degree. Next, even though nothing has been specified, okay, then also we can understand that as if you sum up all those angles, it is not 360 degree, and we know for one complete revolution it is 360 degree. So we must understand that there is another dual, we can denote with delta 2. Okay, and how to get it? So 360 minus all those angles, so it is 165 degree. And next speed of the cam, it is given 200 rpm. And so these are the main given data. Okay, and now what is your task? You have to draw the profile of the cam, that means cam profile designing you have to do, and determine the maximum velocity and the uniform acceleration of the follower during both the strokes, outstroke and return stroke. Outstroke means right stroke or ascent stroke, return stroke means when it is coming down. Okay, so for this, for finding on the numerical values directly, you can have the own expression. Okay, already we have the known expression, directly you can use. Okay, so I hope up to this much everyone is clear. So let me know. Okay, so now our first step, first step is drawing the displacement diagram. You will mention it. Okay, first place, displacement diagram. Okay, first step is displacement diagram. Okay, so in that particular case, what you have to do, first thing will be to consider the proper scale and mention it. Okay, scale you have to write it. Okay, along x-axis and along x-axis what is used. Okay, so along x-axis and along y-axis you have to mention. So along x-axis for drawing the displacement diagram, what we denote? Along x-axis we denote the cam angular displacement theta, and along y-axis what we consider? We consider the lift of the follower, y or h, whatever you denote it. Okay, so that is the thing. So this is the lift or displacement itself, and this is theta. So along x-axis you have to write, suppose, right, you will just look at the values, whatever the values it is given, 60 degree, 90 degree, like this. Okay, 45 degree, after that 165 degree. So you just have to consider a suitable scale, maybe 20 degree. Along x-axis you can consider 20 degree itself equal to, suppose 20 degree equal to 1 centimeter, that you will draw. So in that way you can very easily think of 60 degree, 90 degree, like that, how much will be it. Okay, similarly along y-axis, how much is the lift given? Lift is given 28 mm. So drawing 28 mm exactly as 28 mm will not be any problem. So you can consider in 1:1 scale, or 1 mm equal to 1 mm. So 1:1. Okay, up to this much I hope all of you have understood. It is nothing but 1:1 scale. Okay, just let me know someone. I hope all of you have understood up to this much, no confusion.
Yes, sir.
Okay, thank you. So next, what is our task? You just have to draw the displacement diagram considering uniform acceleration and uniform retardation scheme of movement for both ascent, this is the ascent stroke, and this is the descent stroke. Okay, so along you will just draw this x-axis and y-axis. Okay, one horizontal line and vertical line. Then as per scale, what we have to do, we have to mark the ascent stroke, descent stroke, etc. So this is theta suffix a, ascent stroke angle. So what was it? The angle was given as 60 degree. So as per scale, how much I have to, where I have to locate it, how much I have to draw? Or if I draw the whole horizontal line, where I have to locate it? What should be the length? I have considered 20 degree equal to 1 centimeter. So as per that scale, 60 degree becomes 3 centimeter. At 3 centimeter, I have to mark it. Then we have dual for 45 degree. Okay, so 45 degree, like you have to consider. Okay, so as per scale, you'll just the first dual, you'll just mark here. Next, once again, we have the descent stroke theta suffix d. Okay, so for that we already have the angle as 90 degrees. So as per scale, we'll just up to that much we'll just mark. And after that, there is another duel at the last. After descent, there is another duel. So I have already discussed in the last class, if there is descent or duel at the end of a descent, you may or may not show it. Even if you show it, it will just look like a flat line here. Okay, so we have not have not shown here. Okay, so that's that. Next, what is our task? We already know it's a uniform acceleration and retardation scheme, and we have to draw the displacement diagram. So what we will do after doing this, okay, then already as per scale, this y-axis also you have to draw considering the leaf value, and you will complete this particular rectangle. Okay, then wherever already you have marked, you will just mark them also, complete them. Okay, and we have completed the rectangle. Next, our task will be to, we have to divide the theta a and theta d, okay, into some equally spaced division, or and it has to be even. So minimum we go for 6 divisions. So we have divided 6 equally spaced division. Okay, you have to just see if it is 6 centimeter, 1 centimeter each. If it is 3 centimeter, 0.5, 0.5 like that. Okay, you'll be locating and you'll be drawing this particular vertical lines. Okay, so all those vertical lines you have to draw. Similar is the case in case of descent stroke. So you can go for 6 or 8 number of division. So you'll just equally mark, okay, and you'll draw these lines, vertical lines, and all those divisions you have to number. So starting from 0, okay, 1, 2, 3, 4, 5, 6. As now at 6, now this is, which stroke is this from here to here? Can anyone tell me? This is the dual stroke. Okay, and during dual there will not be any movement of the follower. That's why we don't have to divide it. Okay, throughout the dual actually it will be same only, but in the ascent as well as descent actually some change is happening. The follower is moving, so some change is happening. So that curve we want to get. Okay, so that division has been done. Next thing is, as for drawing displacement diagram for uniform acceleration and retardation scheme, the mid vertical line you have to consider, that is the third line, this one. Okay, we'll consider this, and whatever is the number of division you have done here, that is 6 division, you have to mark 6 division, equally spaced division here also. Okay, so suppose somewhere here, 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 and last one will be here. And after that, from this, for once for the ascent time, okay, uniform acceleration, and next is uniform retardation. So you'll you'll join these points from the origin. Okay, so this one, next this one, next this one. So this corresponds to, from this side if we consider, it will just be the diagonal. Next this line, next this line, and so on. Similar is the case in case of this particular descent stroke. Okay, we'll be considering this line, the middle one, and we have to mark it in 6 equally, the vertical position, you have 6 equal division, and we'll be starting joining from here. First, in this descent stroke, we'll join from here, because this way only, towards right only, where the theta is increasing. So this descent stroke starts from here. So we'll start joining this line here. Okay. Next, our task is just to find out the point of interest, the main actual point through which we are going to draw the line. Okay, so first this line will draw. This first line, it meets with the first vertical here. Second line, it meets with the second vertical here. Third line meets with the third vertical here. Similar is the case. This one, this meets here, this meets here, and the last point is here. So what we'll draw now? We have to draw a smooth freehand curve passing to this point. So we have drawn this particular line. Okay, so it's just like this. Next, ascent stroke is over. Now it is dual stroke. Now at the end of ascent, that means the position of the follower is here, and now there is no movement. So here only you have to make it dark. Okay, that means throughout this descent stroke, this much is the already the lift was up to this much. So this is the thing. Next, once again, we already, just like the previous case, we have located this point, this point, this point, etc. Wherever this oblique line meets with the vertical lines. Okay, and we have to draw this particular line. Okay, that curve, smooth freehand curve passing to the point, and this completes the displacement diagram for this. Okay, and don't forget to name those points of interest. So corresponding to first division, it is 1 dash, 2 dash, 3 dash, like this. We have given the name up to 6 dash, and next you can start either from 7 dash or 6 dash. Because why we have given the same name 6 dash, 6 dash? Because there is actually no change in the as it is dual, there is actually no change in the velocity. Okay, whatever is the location here at the whatever is the location of the follower at the end of the uh, ascent stroke, which itself is the starting of the dual, first dual, it will be the same in case of end of the dual stroke, or you can say the beginning of the descent stroke. Okay, understood? So with this, actually the displacement diagram is now over. Up to this much, any question, or if you have understood, let me know. Any question also you can ask. Okay, others?
Understood, sir.
Okay, thank you. Okay, so now our next task is, second step is to draw the cam profile. Okay, you will mention about second step, draw the cam profile. Okay. Okay, now in this particular case you have to mention the assumptions. So in the second step you mention about the assumptions. So what are the assumptions? Basically you will consider, here it is, what kind of follower is this? Already it is given as roller follower as per the question itself. Okay, and assumption you will consider, if the cam is rotating, considering cam to be rotating in clockwise direction, we will consider the follower is rotating about the cam in the anti-clockwise direction. That is your main assumption. Next you have to mention about the, so that is the main assumption, and that is the kinematic inversion principle, and that is the assumption. And what we have to do, the first step will be to, and the radius of the circle, you will write radius of the circle equal to, so in this particular case what it should, you have to consider, the minimum radius of the cam, that is r suffix c, added with the roller radius. So this is the thing, rc, you have to draw the circle considering rc plus rr. Okay, that much value. So what will be the value in our case? RC plus RR. RC is given as 25 millimeter and roller radius is 7.5 millimeter. That means 30 RC plus R equal to RC plus R suffix R. Okay, it gives us 32.5 millimeter. Okay, what you have to consider in your this one, compass. Okay, considering the pencil compass, you use the pencil compass and draw one circle having this kind of radius. Use pencil compass and do this. Okay, so as these are graphical methods only, so these are graphical method, right? So graphical method means you have to have all those geometrical instruments, as well as scale is, considering proper scale or drawing as per proper scale is very, very important. How actually we get the all those data from graphical methods? So basically from the graphical method, if you look at the whatever you have drawn, whatever curvature, etc., whatever is there, and if we know the scale, we should be able to get the actual value. That is the meaning of graphical method. Okay, that's why you have to have all this. I hope all of it is clear to all of you. So now what we have done.
Yes, sir.
Okay, thank you. So now considering that particular value, you just draw a circle. So considering this as the center, we have drawn this particular circle whose value is how much? 32 point, radius is 32.5 mm. Don't mind my drawing. It's not that it's easy to draw here. Okay, now we know that it's a roller follower, but is it a inline type of roller follower or it's a offset type?
Offset, sir.
Correct, offset. That means it is not actually passing through
Center.
correct. So that means in our case, actually, if this is the center of this particular, already you have drawn now. Okay, so the roller position will not be here. Okay, but it is somewhere, it is not correct. Okay, but it is somewhere here, center of the roller. Okay, which is towards right. And how much is the amount? 12 mm. 12 mm towards right. Okay, 12 mm is the offset. Correct. So that's the thing. So now for that, what we have done, so you have to consider, as we are talking about, it is offset by 12 mm. Now, is it offset only at the beginning, only at the first step, or throughout the movement it will be offset? It has to be offset.
Throughout.
Yes, correct. It's throughout its offset. Okay, and we are considering about kind of movement. In the kinematic inversion, we have considered as if the follower is moving around the cam like this. Okay, so that means throughout all the positions of the whenever we are tracing it. Okay, actually it should be offset, and that's why what we have done, considering the offset value. Okay, we are drawing a another circle, concentric circle. Okay, and this for this one, what should be the radius? Okay, so in that particular radius, actually, it is the offset considered. Radius will be the offset value, that is 12 mm. Considering 12 mm, you have to draw another circle. So why we are drawing this, all of you understood, right? Because throughout the positions, okay, it has to be 12 mm offset, and which if we draw actually later on, you'll see. So that's up to this much is clear, right? Okay, so now actually what happens if we draw the tangents, okay, through this particular circle, the smaller circle, then actually we can understand that at all the position actually it is as it is the radius of the smaller circle, it is not going to change. Throughout it is 12 mm only because it's a constant radius. If you are talking about a circle, it's a constant radius. So if I draw this or drop the tangents, so at those locations actually it is at 12 mm. Okay, so from here to here it will be 12 mm, correct? And now if we draw this particular tangent, we'll start from this vertical position only. You can even start from some other location, but that will not be proper justified because due to gravity, etc., there may be misalignment, etc. Okay, but it's possible to even start from some other location, but it is not a standard way to do so. We generally consider the vertical position to be the beginning position. Okay, so what we'll do, at it is 12 mm, so roller location should be somewhere here, that means, correct? So now considering this 12 mm, okay, this tangent, this vertical position, actually we have to draw this particular ruler here. And ruler, how to draw the ruler? Considering the ruler radius. Okay, it has to be that much value. So what is the ruler radius given? It was 7.5 millimeter. So considering setting 7.5 mm as the distance, okay, length, okay, you have to draw the ruler position here. You will draw the ruler position here. And that means, and if you draw this particular tangent, so tangent means what? If we're talking about a tangent, if we're discussing about the tangent, so a tangent at how many locations of a curve a tangent touches it? What is tangent? So if this is the curve in our case curve is circle, okay, if we're talking of drawing a tangent, so tangent always touches it only at a single point, correct? Only at this point actually it is cutting. Okay, so this kind of thing, these are not tangent, these are chords, correct? They should not, and tangent always passes through a single point only. Okay, so now this is a tangent. If I draw suppose like this, it's also is a tangent. There may be infinite number of tangents. Okay, it's a tangent, all are tangent. So basically it touches the curve only at a single point. Okay, so you should not draw like this and say that it's a tangent. Okay, don't do that. So now if it is the tangent, okay, if we think of the tangent, so basically throughout, if we consider as if we are rotating around it, okay, then if we keep on drawing the tangent, so that particular position, suppose if this is the position, center position, if this is the position for this tangent, if this is the position for this, if this is the case, so if this is the case, so we can be sure that with respect to this particular center, okay, this distance is always the radius distance, correct? So that if you draw the perpendicular, this much is always the exact radius. Okay, this much is exactly the same value. That means it is, if we with respect to the tangent, it is always lying at the same value. That is, if we are discussing about the offset, so throughout of this particular center, okay, if we draw with respect to this tangent to this particular smaller circle, which is shown here, so then whenever it is moving like this, so throughout of it will be at 12 mm if you drop the tangent. But if you draw something else, if it is suppose somewhere something like this, if you draw, then this much value, that is from the center only, this much value will not be equal to the area. Correct? That is something else. But up to this much only it's okay. Okay, I hope it's okay with you. So that's why actually we have drawn, that is the purpose of drawing this particular smaller circle. Okay, now this is this O, okay, this is the initial position. Okay, this is the O is the center of the circle, sorry, and O dash we have given, O dash is the center for this particular roller. So this is the starting point of the roller, which is offset by an amount of the 12 mm. Up to this much clear, everyone? I hope it's clear. So now what we'll do, you just draw or join the centers of both the circles. So center of this smaller circle with the center of the roller. Okay, this is the line. And now with respect to this line, you just have to divide the angles, theta A, delta, theta D, etc. Okay, so that is the baseline, that means from this one. From this line, we will just use your protector and find out the angles. Okay, so what are the angles? What are the angles given? 60 degree, then we have 45 degree, 90 degree, and remaining will automatically be 165 degree. So you have to mark at 60 degree, 45 degree, 90 degree, etc. So 60 degrees. So with respect to this, it is, so here it ends. This is the 60 degree. So this much angle is theta A. This is theta suffix A, you will just mention. So now from here, dual is there 45 degree. You will just, now this becomes the baseline, second line. Okay, this is the delta 1. Okay. Next from here we are starting the descent stroke. Okay, so that angle 90 degree you have to mark. Okay, the division you have to do up in the circle, and automatically the other angle will become delta 2. That is the up to the division. Okay. Next, what we have to do, we have to divide them. Okay, divide this ascent stroke and descent stroke into the same amount of division that you have done in the displacement diagram. So here it was 6, here also it was 6. So 6 marking, 6 equally spaced marking you have to draw. Okay, and in the ascent stroke as well as in descent stroke. But remember, okay, so while making the marking, you just mark the, suppose this is the 60 degree angle, suppose, then 6 division if you have to do, then it is angular division. Okay, suppose 10 degree, 10 degree, 10 degree at 10 degree interval. So you'll, with respect to the protector only, what you'll do, you'll keep the protector here. Okay, whatever is the angle it was there, divided by 6, and only just you don't have to draw these lines. Okay, in the previous case, as it was inline, in the previous case, previous problem, it was inline. So directly we have drawn like this. We have divided like this. Suppose 6 division. Directly we have started drawing these lines. Okay, right now don't mind my drawing. This is not proper. Okay, so in the previous case, as it was inline, directly we have started from here. But right now we know that only if it is tangent to the smaller circle, then it's going to be this one, it will remain offset throughout. Okay, so now what we'll do, you just mark those divisions here and give them number 1, 2, 3, 4, 5, 6. Similarly, in the descent lift, you don't have to, not lift, it is dual, you don't have to mark anything, you don't have to divide. Okay, next, once again, this angle will be this only from here to here. Okay, that descent stroke, but we considering the your this protector, using your protector, you just mark the points. Okay, mark them and name the points. Okay, 6 division. Next, what we have to do, as we know that through these points, if we draw the tangent, then all those locations, at all those locations, actually it will be tangent. It will be offset by that much amount only. Okay, so that's why we have started. These points are there: 1, 2, 3, 4, 5, 6. Okay, so considering these points, we will be drawing from that particular point. We will be drawing tangent to the circle. Okay, so from 1, this is the tangent. Okay, it should not be a kind of, it should not pass through like this through the circle, but it should be tangent. Okay, so you can even draw like this up to, you can pass it. Okay, but it will look haphazard. That's why we have, wherever they meet, okay, we will stop there only. Okay, you don't have to like draw up to this mass or like this or so. Okay, you don't have to extend the lines tangent, but just you make sure that it looks like tangent. Okay, so similarly this and so on. Okay, similar is the case in case of descent stroke. Okay, first point is starting of descent is at the end of dwell. So starting from this is the up to this circle, this is a tangent. From here it's a tangent. Similar is the case, from here it's a tangent, and the last point is from here it's a tangent. Okay, up to this much, any confusion, anyone? How we have drawn the tangent? It looks like the sakri that you burn in the Deepavali, right?
Sir,
So
how
that means in
to
those
locate
cases also,
a circle?
please repeat once again.
Sir, how to locate the circle?
How to locate the circle? So it is already given. Okay, circle is you already have divided the points. Okay, located these points. So it's something like this. If you already, situation is something like this, you already have this particular circle, you already have some points. Okay, suppose this point you have, this point you have, suppose this point you have. Okay, and your task is to draw tangent to the circle. That is that kind of thing only it is happening. So if you draw tangent from this circle, so it will be something like this. Okay, something like this, correct? Something like this. Automatically it will become something like this, correct? These are the tangents from these points. Okay, and what we are doing in our task, we are not showing these extended parts. Okay, up to the tangent part only we are interested. And next one, another confusion you may have, why in this particular case we are not going up to this side. Okay, because this side is with respect to ascent stroke. Okay, so it's something like this. Okay, so these points, suppose these points are with respect to ascent stroke, and suppose these points are with respect to descent stroke. So from all the ascent stroke points, okay, we'll be drawing tangent like this, because like this, okay. Similarly is like this. Now there is a dwell in between, so we are not interested in the dwell. So these points are now these points are with respect to related to the descent. So once I will start from this, okay, from this. Understood? Is it clear now? Is it clear now? Let me know. Okay, thank you. So now our last two steps are remaining. So next is what is the, just like in the previous cases, whatever we have done. So now already we are ready with the division. We just have to, from the displacement diagram, we just have to locate or measure these distances, this extension distances, and that much extension we have to do. So for the first division, this much from here to here, this is the amount of extension. So along the tangent in the first division, you will be extending this much. So right now it has already overlapped, it looks haphazard, but this much extension you have to do, and give the same name. So it is 1 dash. So one point is already there, so 1 dash. Similar will be this like measuring this much distance, and in the second division you will be extending by that much amount. So make this 2 dash. Similarly, you will be like this much amount you will be looking for. Okay. Sorry, in the second case it is up to this much. Sorry. 2 dash point is here. So 3 dash point is here. Okay. So now for the third case, third vertical up to third 3 dash. So along the same tangent only, don't make it vertical or something like this. Along the tangent only, you just extend by that much amount. Next, up to this point, you will be measuring. Okay, that much extension you will do. Okay, similar is the case of 5 and 6. Okay, 6 up to this much, and make it 60. So it is ascent stroke is over. Next is dual stroke. You don't have to measure. Even if you measure, it will be the same value. So it will be same only. So once again, that much extension along this line will do. Similarly, these values will measure the corresponding values, and corresponding extension you will do up to this one, like this. Okay, and last point is 12 dash. They are at the same point. Okay, so that is, it will be the same point. Okay, So we have done up to this much. Any confusion up to this much?
No, sir.
Okay. Next thing is, you see at the very beginning what we have seen. This is the center of the, like, on this circle. Actually, it is the center of the roller, and we have the roller. So now all these points, basically 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, once again 6 dash, 7 dash, etc. These are the, actually, during rotation of the follower that we have considered. These are the center point of the follower. So what will be our task now? To get the last curve, okay, the position actually which is in contact with the cam. Okay, we know that the cam and follower, they are always in constant contact. So if this is the roller follower, suppose this is the surface of the cam, okay, they will be always in contact. Even if whenever it is moving like this, it should be in contact. Whenever it is moving like this, follower, it should be in contact, and so on. That means if we can draw this inner half of the curve of the follower, and if we draw like this, a curve like this, basically that is nothing but the surface of the cam. So same thing we are just doing. So considering 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash as the center, once again this roller will just show. So there are two ways. One is you can completely draw the roller in each and every case. Okay, so considering this as a center, can completely draw the roller. Don't mind my drawing, these are not that good right now. Okay, and another task is you can draw the inner half of the circle. Consider, because inner side only will be in direct contact, so that is up to you. You can directly draw the whole circle also, whole roller. And once you are done with the all roller position, okay, what you have to do, starting from this particular point, you have to draw a smooth curve passing through, it should be tangential also, passing through these points, okay, inner points, and join them with a smooth curve. Okay, up to this much it is ascent stroke. During descent stroke, it will be constant radius curvature. So you can directly use the pencil compass and constant radius curvature up to this much. Next, once again, already you have drawn all those positions, and you just connect them. Okay, up to this much. Next, don't forget there is another dual. Up to this much you already have the division. So here, considering this much as the radius, as it is dual, draw another constant radius curve. Okay, so now this completes the task, and show it. Okay, that is, this is the required cam profile. Okay, and this completes the problem. Have you understood, all of you? Just let me know. Don't miss the last point. Okay, you have to close it. It's a cam is closed entity only. So this completes how to draw it. Have you understood or not? Just let me know.
Understood, sir. Understood, sir.
Okay, thank you. Okay, thank you. So this is the drawing part is over. After that, actually, it's just using your known formula. Okay, just it is for uniform acceleration and retardation. So already we have gone through the expression that we have. Okay, the standard expression you will use, and just find out the values. This task you can do after drawing also. Before drawing also you can do, because it is only using the known expression. So for that, omega equal to 2 pi n by 60, because omega will be required later on. So twice pi n by 60, all of we already know. Considering this, we have obtained this value. Okay, n was given as 200, so 20.94 radian per second. Then for this is during outstroke. Okay, so V max we have, okay, 2h, h is nothing but the leap, omega by theta. So, but one thing is that all those values are now given. Okay, this is a known expression, values are given, just find out, just solve it. Okay, and but we advised, okay, remember, so these angles theta a, theta d, etc., it has to be in radian. That's why 60 degree into pi by 180 degree we have done, okay, to convert to radian. So it has to be in radian. Don't make this mistake. Sometimes people make this mistake only, students make this mistake only, and we use the proper units. If it is acceleration, whether it's acceleration or velocity or like that, okay, corresponding proper unit you have to consider. Okay, and always it has to be in radian. Similar is the case during return stroke, but it has to be like now it will become theta d, okay, for return stroke and so on. Okay, so with this we have completed the whole problem. So have you understood the whole problem? Just let me know. So I hope you people have understood it. So you'll be able to draw it, right? So you now have the confidence to do solve similar kind of problems, right? I hope all of you can solve this kind of similar kind of designing of cam profile problems. Okay, just practice some of them. Okay, so and with this basically we have concluded. We are going to conclude this particular session. So thank you everyone for joining.